So we're learning about solving compound inequalities. First off, let's define what a compound inequality is. It's when we have multiple, specifically two, inequalities combine in one. They come in two different situations. You can have an and type of compound inequality. We can also have an or type of compound inequality. Okay? And is when both are true, both statements are true, and or is when either statement is true. Okay? Now let's take a look at an and situation. So and is written in the way that you see here, where there's two inequalities, less than and a less than or equal to. And x is in the middle, or the variable is in the middle. A smaller number is on the left. In this case, it's 9. And a larger number is on the right. In this case, it's 13. Okay? So, and we want all the values that are in between 9 and 13. Not including 9 because there's just a less than symbol. But we are including 13 because it's a less than or equal to 13. So graphing this, I would leave an open circle at 9. This is a number line here without arrows. Here that we can add the arrows. And we would have a closed circle at 13 because we want to include it. And then we would shade everything in between because we want all the overlap of values that are greater than 9 and less than or equal to 13. So any numbers that are in between here, we're happy with. But not 9 because it's an open circle. So then interval notation, in this case, you can see that we're not shading to the left forever and we're not shading to the right forever. In the past, we've looked at negative infinity and positive infinity as part of our interval notation. In this case, we actually go from 9 to 13. I'm going to use a parenthesis for 9 because it's an open circle. And I'm going to use a square bracket on 13 because it's a closed circle. Another thing that I don't have here written here, but we can include, is set builder notation. And it'll be very similar to our top example. So I'd start with a fancy bracket, all x values, such that 9 is less than x, which is less than or equal to 13. And then close with a fancy bracket. Okay, now an or situation will be a little more obvious because we'll have the word or in between the two different inequalities that we're talking about. I usually like to put the less than and the smaller number on the left side and the larger number with the greater than sign on the right side, like how it's written right here. So in this case, finding 11, that's right here, and I would put a closed circle because it's less than or equal to, and I would shade to the left because that's less than, and put an arrow there. Then, or greater than 13. So I would put an open circle at 13 and shade to the right. So this is a typical or situation where we're shading towards negative infinity and towards positive infinity because we could have values that are either going to the left or going to the right. And then there's this gap in the middle that we do not want. So in this case, that's numbers that are bigger than 11 up to 13. We don't want those values. All right, so now interval notation for this is a little more complex. So it's basically we have two separate interval notations. First, let's focus on the left arrow here. So we're going towards negative infinity on that one. And it ends at 11. Since it's a closed circle, I'm going to put a square bracket. Okay, now we're going to do a whole nother interval notation for the right half. But to combine these together, we use this symbol. This looks like a big U. It means in union with. So we have this left interval notation in union with, now let's do the right interval notation. Well, that one's going towards positive infinity, so I'm going to leave a little space, put a positive infinity with a parenthesis on the outside. Now, the value that it starts at is 13. Since it has an open circle, I use a parenthesis to show that we don't include 13. So altogether, we've got the left interval notation, the right interval notation, and then this union symbol in the middle, in union with. So how you would read this is negative infinity to 11, including 11, in union with, starting at 13, not including it, all the way up to infinity. All right. Now, set Builder notation, start with a fancy bracket, all x values such that, and basically we're copying down what we see in the example. X is less than or equal to 11, or x is greater than 13. Close the fancy bracket. Okay, let's try solving some of these, because we're not always going to get nice ones where it's just x by itself, like we have in these examples. So this is an and situation. I can tell that it's an and situation because it's this one where the x is in the middle. We've got two less than type symbols. So that is an and situation. One clue is that you'll know if it's an or situation because it'll have the word or in it. So if I want to get x by itself here, I have to get rid of that 5. It's 5 times x. So the way I'm going to do that is divide by 5. Now this is kind of weird, and I kind of like these because we can do it to both sides, but in this case we have like 3 sides or 3 spaces. So we can divide the 15 by 5, and we can also divide the 10 by 5. So we're dividing 3 places by 5. Now it cancels in the middle like we want, and so we'll have x in the middle. We have the less than or equal to signs on either side. And now what's 10 divided by 5? Well, that's 2. What's 15 divided by 5? Well, that's 3. And there we have it. Now we have our inequality. So the x values are from 2 to 3 is what this is telling us. So 2 is less than or equal to x, which is less than or equal to 3. Now let's write that in all the different notations. Let's start off with set builder notation since it's very similar to what we just wrote. All x values such that 2 is less than or equal to x, which is less than or equal to 3. Always start with the smaller value, end with the bigger value. So 2 first, 3 last, and do less than symbols as you go. All right. Next, let's graph it. So let's make sure we put 2 on there and 3. We're going to have closed circles on each of them. And we want all the x values that are in between them as well, so I'm going to shade in between. So like that. For interval notation, we don't have any infinities going on here, so we're starting at 2, ending at 3. And both are closed brackets because, square brackets because we have closed circles. So there we go. Okay, so number 5. This one is also an and situation. One clue is that there is no word or. Okay. We can do something similar like we did to number 4. We want to get the r by itself this time, so we have to get rid of the minus 10. So the way you do that is you add 10, and we'll do that in all 3 areas. So the goal is always to try to get the variable by itself in the middle. So we did that successfully already. The symbols are going to stay the same. Negative 11 plus 10 is negative 1. 8, or negative 8 plus 10 is positive 2. So negative 1 is less than r, which is less than or equal to 2. In set builder notation, we'll have all r values such that negative 1 is less than r, which is less than or equal to 2. This is good. We have the smaller number on the left, negative 1, the bigger number on the right, positive 2. With less than symbols as we go. Next, let's do the graphing. This will look very similar to the last one of negative 1, positive 2. Now the difference here though is notice how there's just a less than symbol next to the negative 1. That means we'll have an open circle where the negative 1 is, but we'll still have a closed circle where the positive 2 is. Shade everything in between for an and situation. Okay. And now let's do our interval notation. So starting at negative 1, we're going to use a parenthesis on that side since it's open circle, ending with 2, closed square bracket because it's the closed circle. All right, so now this next one, we have an or, and hopefully that's obvious. It's got the word or. Now what I like to do, because sometimes it can be kind of confusing, I like to shade, or I've got a highlighter here, and really separate the two inequalities, right? We have one on the left and we have one on the right. Use that word or to really separate the two. Okay. Anyway, so you basically have two separate things to do. So on the left side, I would multiply both sides by 9. Cancels on the left, and I would have n less than or equal to negative 9, right? Negative 1 times 9. On the right, I would divide both sides by 10. That would cancel here, and I would n greater than or equal to negative 5. Okay, so now, maybe I can erase that highlighter a little bit. I can write it in interval notation. So, or sorry, not interval, set builder first. N such that, and I always like to start with the less than symbol in the smaller number. So that's the less than or equal to negative 9. So less than or equal to negative 9, or n is greater than or equal to negative 5. Negative 5 is actually bigger, right, than negative 9. So there's set builder notation. Now graphing. So let's mark where negative 9 might be and where negative 5 might be. And we're going to put closed circles on each. For the negative 9 one, we're less than that, so that's to the left of negative 9. For negative 5, we're going to the right because we're greater than that one, so we're going towards the outsides. So we are okay with any value that is less than or equal to negative 9 or greater than or equal to negative 5. Next, interval notation. So this is the kind of the long interval notation. So let's focus on the left half of this. So we're going from negative infinity to negative 9, and we're including negative 9, so square bracket. In union with, starting off with negative 5, we're including it, so square bracket, and we're going all the way up to positive infinity, parenthesis there. All right, number 7, another similar one. Let's separate these with some sort of shading, or I'm going to use a highlighter. On the left side, divide by 6. Cancels, and we have x is greater than or equal to 10. Left side, we want to get rid of that 3, so subtract 3 from each side. That cancels, and we get x is less than or equal to 7. All right. So writing our answer now, set builder notation. All x values such that, I always like to start with the less than and the smaller number, so that's x is less than 7. Or we're okay with values that are greater than or equal to 10. Now, if you mix them around and put the bigger value first, I'm not going to count it wrong, just so you know. That's just the habit I like to get into. I think it helps then when we get into the graphing, we can focus on the smaller number first, 7, bigger number next, which is 10. And then we can do closed circles on each of these. We want less than 7, going to the left, more than 10, going to the right. Okay, interval notation, negative infinity, up to 7, including 7, square bracket. In union with, square bracket 10, we're including 10, all the way up to positive infinity. All right, a couple more examples here. Number 8 is another OR, so I'm going to highlight, it's really show the separation between the two. Okay, so let's focus on the left inequality first. So we're trying to get b by itself. First, I'm going to subtract this 10 off. That cancels, and I have negative 6b less than or equal to, that would make now negative 36. Divide both sides by negative 6. Now be careful, we're dividing by a negative 6, therefore the symbol is going to flip. So it's going to be a greater than or equal to, negative 36 divided by negative 6 is positive 6. So yeah, be careful with that flipping there. See how it's different when we divide by a negative value. Okay, all right, over on this side we've got subtracting 9. Here, let me use a different color here. Subtract 9, that cancels, and we have 8b less than or equal to, that would make negative 40. Then divide both sides by 8, cancels on the left, and b is less than or equal to negative 5. Okay, let's put that together in an answer. So all b values such that, let's start with a smaller one, so b is less than or equal to negative 5, or b can be greater than or equal to positive 6. Graphing, negative 5 on the left, positive 6 on the right. Close circles for both, and just like the other OR situations, we shade to the outsides. Okay. And then interval notation. Again, you can kind of find a pattern here. We go from negative infinity to negative 5. In this case, square bracket. In union with square bracket 6 to positive infinity. Right, and we're using square brackets because of the closed circles. Okay, now we haven't seen one of these in a little bit. This is an AND situation, mostly because there's no OR. There's no word OR, but also because it's written in this long one inequality. We're trying to get a by itself. We're going to do a two-step in this case. So the way we have to get rid of the negative 9 and the 5. We have to cancel out that 5 first by subtracting 5. Cancels in the middle. On the left side, we'll have negative 18 less than or equal to. That's a negative 9a. Make sure that negative sign sticks with the 9. Less than positive 18. Next, we're going to divide by negative 9. So be careful with that. We're dividing by negative 9 in 3 locations. Cancels in the middle. Since we divided by a negative, both signs are going to flip on each side. So we're going to have 2 greater than or equal to a greater than negative 2. Okay, now this is fine, except we always like to use less than symbols, and we like to have the smaller number first. So I'm going to flip everything so that we're starting with the smaller number first. So that'll be negative 2 is less than a, which is less than or equal to 2. Notice how I also flip the signs when I flip the numbers. The only thing that didn't move is the a, right in the middle. All right, now set builder notation, all a values such that negative 2 is less than a, which is less than or equal to 2. Graphing, negative 2 on the left, positive 2 on the right, and we'll do open circle on the negative 2, close circle on the positive 2. Shade everything in between. Open circle for a less than, closed circle for a less than or equal to. And now, interval notation. We go from negative 2 to positive 2, parenthesis on the negative 2, square bracket on the positive 2. All right, 2 more to check out here. Here's an OR situation. Let's really separate the 2 equation or inequalities here with the highlighter. On the left side, I'm going to add 3. That cancels, and I have r greater than 5. On the right side, we have a couple steps. First, I'm going to add 1. That cancels, and I have negative 10r greater than or equal to 70. Divide by negative 10. So dividing by negative is going to flip that sign. So now it's less than or equal to. And 70 divided by negative 10 is negative 7. All right. Write that in set builder notation. So all r values such that I'm going to start with the smaller number. R is less than or equal to negative 7, or R is greater than 5. Graphing, we've got negative 7, and we've got positive 5. We are going to graph to the left and open circle graph to the right. So then this last one is going to be an AND situation. We're trying to get the B in by itself. So first step is going to be add 4 in all 3 spots. Cancel in the middle. Then we'll have negative 70 less than or equal to. That's a negative 10 in the middle. Negative 10b less than 10. Now we have to divide by negative 10 in all 3 spots. We have cancels in the middle. We're going to have to flip the sign. So 7 is greater than or equal to b, which is greater than negative 1. Let's rearrange all that. So the smaller numbers to the one side. And I'm actually just going to jump right into set builder notation. So all b values such that negative 1 is less than b, which is less than or equal to 7. Graphing, negative 1, 7. Open circle and going to the left on the negative 1. Close circle and going to the right on the positive 7. And lastly, interval notation. So negative infinity to negative 1 with a parenthesis. Nope, didn't leave myself much space here. In union with close bracket 7 to infinity. We're going to stop there for the notes. I know there are more in the notes, but I'm just going to focus on those, and then in the homework, only focus on 1 through 8.